The year 1901 stood on the brink of scientific transformation. A new era was unfolding, an era where scholars pushed beyond the boundaries of the unknown, reshaping the foundations of physics, chemistry, and biology. Tonight, Stockholm, a quiet and cold city, was about to witness a moment that would forever alter the history of science. In the ground hall of the Royal Swedish Academy of Science, anticipation hung thin in the air. Each document holding the essence of discoveries that would redefine the century. A hushed excitement spread through the gathered minds. A congregation of some of the greatest scientific intellects of the time. Among them stood Max Planck, the man whose theories would soon usher in the quantum revolution. His gaze remained fixed upon the page that carried his pioneering path. Not far from him, Jacobus Henricus, Hoff, whose scientific landscape sat reviewing his own notes. Within them lay the meticulous formulas of osmotic pressure, a discovery that had challenged conventions and paved the way for an entirely new understanding of solution and equilibrium. Elsewhere, Guglielmo Marconi, the brilliant mind who had sent the first radio signal beyond the horizon, stood with quiet pride. Beside him, Karl Landsteiner, the physician who had unveiled the mystery of blood groups, forever revolutionizing medicine, observed the room with composed dignity. And then the moment arrived. As the first recipients of the Nobel Prize were announced, silence fell. Then a name ranged through the chamber. Jacobus Henricus, Hoff, the first ever Nobel in chemistry, honored for his groundbreaking work on osmotic pressure. The crowd erupted in applause. Hoff rose from his seat, his eyes reflecting the weight of years of relentless dedication. His theories, once challenged and scrutinized, had now been recognized as a cornerstone of modern chemistry. Knowledge science was coming alive in ways no one had imagined. The air carried the scent of rain. Rotterdam, a city breathing between canals and stone buildings, stood in quiet contemplation beneath the soft house of an autumn dawn. Inside one of its old homes, nestled among the ever-present maritime winds, a child was born, Jacobus Henricus Hoff, the third of 7 siblings in a family where medicine and science ran through their veins. His father, a respected physician, envisioned his son following the same path. But even in infancy, Jacobus seemed to be destined for something else. There was a curiosity in his eyes, an insatiable hunger for discovery. While other children played, he wandered through botanical excursions, observing the delicate dance of nature, watching plants grow and silently attempting to decipher the universe's secrets. The school he attended was newly established, its curriculum emphasizing mathematics and the science unknowledgeably nurturing the boy who would one day change the course of chemistry itself. But His passions extended beyond numbers and equations. He was drawn to poetry and philosophy, idolizing Lord Byron, seeing in his verses a reflection of his own thirst for exploration except his journey would unfold not through words but through molecules. His family expected him to become a doctor, but Jacobus had other plans. He secretly attended chemistry classes, sneaking away to satisfy his growing fascination with laboratory experiments. He began his studies at the University of Delft. During his student years, he briefly worked at a sugar factory, hoping to gain practical experience. But the monotonous nature of the job left him restless. He didn't want to process formulas for industry. He wanted to decode the mysteries of existence itself. He continued his studies at Leiden, Bonn, and Paris, absorbing knowledge at an unmatched pace. In Paris, under Adolphe Wertz, he delved deeper into organic chemistry, refining his understanding of molecular structures. Yet his ultimate destination was Utrecht University, where in 1874 he earned his doctorate and introduced the world to a revolutionary idea, the three-dimensional structure of molecules. For years, Van Hoff lived in a world of molecules, equations, and groundbreaking discoveries. His mind wandered through chemical reactions, shaping the future of science. But amidst the formulas and theories, there was one content, a prescience that grounded him, Johanna Francina Mies, his wife, his companion, his pillar of support. On December 27, 1878, as his research reached new heights, he married, not just for love, but for unity, for understanding, for sharing a life between science and culture. Together they built a family, one that balanced intellectual pursuit with the tenderest of home. He had 4 children. He always found time for his family, returning home after long nights in the laboratory to share stories with his children. The Davy Medal, the Paul Le Mérite, membership in the Royal Society of London, the Helmholtz Medal, each recognition a testament to the man who through sleepless nights and ink-stained formulas unraveled the delicate balance of molecules. His other honor was the first Nobel Prize in chemistry. In the quiet lamp of the laboratory, beneath the dim glow of the lamps, science was about to change forever. The movement of water, silent, unseen, yet unstoppable, a force that followed laws beyond sight. His notes reflected the clouds of gases, yet here they unfolded within a liquid, a revelation, a turning point. With hands steady, driven by acceleration, he wrote, skepticism followed, doubt, Raoul's opposition. But Van Hoff didn't yield. More experiments, more proof. And in 1901, science prevailed. The first ever Nobel Prize in chemistry was awarded. How osmotic pressure changed the world? Number 1. Biochemistry. Osmotic pressure plays a vital role in cellular function and regulating water balance inside cells. Number 2. Pharmaceutical. Many modern drugs are designed based on osmotic principles, especially controlled release medications. Number 3. Kidney dialysis. Osmotic pressure is used in dialysis machines to remove toxins from the blood and sustaining lives worldwide. Before equations were written, before formulas were spoken, nature had already mastered this law. Plant roots draw water from the soil, moving from a lower concentration to a higher, one keeping forests alive, sustaining life itself. Marine creatures sense osmotic pressure. Saltwater fish expel excess salt. Freshwater fish absorb more water, adjusting to survive. Nature always knew, long before Van Hoff, long before the ink touched the paper, long before the world finally listened. And so the very first Nobel Prize in chemistry was awarded. But our journey is far from over. This is only the beginning. Van Hoff paved the way, yet science never stops.